Hello, everybody. Can you hear me? Yeah? Cool. I'm Veit, and I'm going to talk about Carp. So I guess the first question is, who has heard of Carp? Except, the people who I told about it. Cool. I still have an audience, but a few people have heard of it. So that's good. The first thing that I want to make clear is that I did not build Carp. A talented game designer in Sweden named Erik Swedeng came up with the idea for Carp and implemented most of the compiler. I'm mostly taking care of the standard library. I do compiler fixes every once in a while in features, but really I'm just patient zero who sort of wound up doing stuff with Carp. And I also have to say that this talk isn't endorsed by him, and all opinions are my own and not his. And there's a first question already.
We need to switch it, right? What is the role of Erik at this point? Is still active?
Sorry, say that again?
The role of Erik at this point is still active in collaborating with you, or you're just
Yeah. So he is kind of the BDFL, benevolent dictator for life, and I'm one of the grunt workers, I guess. So that's okay. I'm all right with that. Okay, so also, we already had that, but this is a chess timer talk, and you really can ask questions at any time. I cannot promise I'll be able to answer all of them, but if I can't, I will tell you, and I will not, weasel my way out of the question. So let's start by talking about the syntax. I call this section Syntax and Other Trivialities because I honestly believe that the syntax is maybe the least interesting part of any language. I know that other people might disagree, and that's fine. I don't feel very strongly about syntax. I'm going to show you some code anyway, just because it's silly to show you a programming language without showing you code. But I mainly want to talk about some of the ideas in Carp and why we went with certain things rather than others. And I also have some ideas about tooling. So to talk about Carp, we have to start by talking about koalas. Many people call koalas koala bears, but technically they're not bears at all, right? They're biologically marsupials, which means they're close to kangaroos and quokkas and that kind of animals. But they look like bears, and so people call them bears. And so the same is true for Carp. Carp looks like a Lisp, and so people call it a Lisp. But if you program in it, it actually feels way closer to programming in ML, like Haskell or Camel, or maybe even Rust. And that being said, Carp syntax is that of Lisp, with parentheses and everything. The goal of that, at least for me, is homoiconicity, which is a fancy word for what you see is what you get, code as a data structure. That's especially important for certain features of Carp, like macros. I always feel like if you have kind of a non-homoiconic language, it gets kind of annoying to write macros if you have to. But again, that's just me. If you feel differently, you can shout out right now or later. I'm happy to discuss this. And now let's maybe look at some code. So this is a function called f, because I'm good at naming things. I called the function f and the parameters x, y, and z. And x, what we're doing in the function is we're taking the nth element of the array x, where the index of the element is determined by the product of y and z, and then we're going to copy it. That's what the little @ symbol is. And so if we ask Carp afterwards, after this function was defined, what the type is, so this is a comment, not an annotation or anything. We don't overload comments to be annotations. This is just me telling you, okay, this is what Carp would output if I call type of f in the REPL. It would tell you that f is a function that takes a reference to an array of a, where a is a type variable. And then it takes two integers, which also makes sense because we index over into an array using integers. And then what we return is a thing of type A, which is one of the array elements. It's the same type variable A that is inside that array. So who here is familiar with type variables and type systems like that? Cool, a bunch. I'm just gonna explain it real quick anyway. This is what we call a Hindley-Milner type system, which lends itself well to being inferred. We also have something called sum types, which are types with multiple constructors. But basically what we have is a language that supports generics and specialization. We can have structs, and we can have types with multiple constructors like optional types. And that's just about it. But the fancy term that we use for this type theoretically is we have a Hindley-Milner type system. Yes?
What about the copy?
What about the copy?
Yeah, what does it mean to do a copy?
Yes. So when we go into more about the language, we're going to see that there is a borrow checker. And what you do here is when you index into an array, you get a reference to the element because you don't own the element. The element is owned by the array. And so what you have to do, if you want to return an honest-to-God element that you can do anything with, you have to copy it. But we're going to look into borrow checking a bit later. It's hard for me to gauge who knows about what features, so if you need me to explain anything, please feel free to ask. This is how we define a type. In this case, that's not a sum type. It only has one constructor. It's closer to a struct. It's an associative array. Associative arrays are very slow key-value pairs. Question?
Is the type system nominal or structural?
Say that again?
Is the type system nominal or structural?
If you explain to me what either of those terms mean, I might be able to answer.
Okay, so you're defining a type called associative array, and that type has some kind of shape or form. And so I was wondering if any kind of a data structure that conforms to that form is able to be kind of unified with that type, or does it need to have the exactly same name as the type we declare here?
The latter. So it's nominal then. Okay, all right. The names make sense if you know what it means. So associative arrays are lists of key-value pairs, very slow dictionaries, basically. If you've worked through structure and interpretation of computer programs, or really any old list book, you've seen associative arrays before. And so all that this type is a type with one member LST that is an array of pairs, key-value pairs, A, B, where those are type variables that we have to capture in the head of the definition. That's not super exciting, but you do know how to define types in Carp now, so that's kind of exciting. And that's about as much as I'm going to show you about the language. If I have some time later, I'm going to give a little demo, but we're going to see how quickly I get through things. And right now I want to talk about the interesting bits, semantics and meaning and that. All right, where in my notes am I? Yeah, what I want to talk about in the semantics of the language is why we chose the features we chose and why we didn't choose some, and certain trade-offs that we encountered when we thought about them. And by the end, you will hopefully understand what Carp is and why I think it's fairly interesting. And if I do a really good job, then everyone will leave the talk with the visceral feeling that designing and building a language is all about affordances, and maybe tools can help us, skew the balance in our favor. All right, so let's talk about the PL goodies first. We have non-hygienic macros. So if you've programmed in most modern Lisps, something like Racket or something like that maybe, then you have hygiene in macros. We have a question here.
Are the macros typed?
Say that again?
Are the macros typed?
They're untyped.
Okay, thanks.
Yeah, they happen as a first thing after parsing. So we can look at that in a second. I want to finish my explanation of hygiene. Hygiene means that you can have name clash. Non-hygiene means you can have name clashes when expanding a macro, if you define a thing that was defined. All right, so the macros are untyped. That's the first thing that's going to expand. Then this expanded code is going to be type inferred. We're going to figure out what the types of things are. And then we have a borrow checker that will figure out the lifetimes of things. And I'm going to go over those a little bit later, but if you have any questions about them right now, that's also fine. Perfect.
I think that languages like Rust have macro systems that have both hygienic and unhygienic or non-hygienic kind of things, and kind of hygiene is regarded as a desirable property in general. So is the decision to go with non-hygienic macros does it have to do with the simplicity aspect, or what's the point of that?
All right. So I think, so the first implementation was done by Eric, and I think one of the first things that I said coming in is we have to make the macros hygienic. It's been 2 years I haven't done it. So the language is very simple. That is due to us asking the questions what needs to be done and what doesn't need to be done. So we defer the features until we really feel the pain of not being able to escape the feature. But we do want to be pragmatic about it. So if we feel this is unergonomic or this is kind of then we're going to fix this, basically. But right now, what we have is a good enough macro system for most of the macros that we've encountered. They just don't introduce many bindings, usually. All right. What we're currently working on then is good auto-generated documentation and dependency management. We have stories for both of these, but they're not quite good enough. We're also working on lifetimes, which is a concept from borrow checking. We don't have that yet because we haven't felt the pressure to add it, and now we have, and so we add it. So this is one of those stories where we're like, can we have borrow checking without lifetimes? If that doesn't mean anything to you, we can talk about that later. And something we also need to work on is tooling in general, which is what I'm interested in. And so why am I interested in that? The compiler has a lot of moving parts and a lot of information. You have information about types, you have information about macros and about lifetimes, and because so much of it is inferred, it is implicit. You don't see it unless you type out the types or you ask the compiler. And that's fine because it reduces cognitive load. You don't have to think about these things, but you still have to have it be explorable, because otherwise when something goes wrong, you have no way of knowing what went wrong. Okay, so in a nutshell, Carp believes that everything should be inferred if possible and exposed to through tools to help us, and we should only have to worry about things if we need to. And at this point, I want to give a little shout out to Pharaoh, because it really deeply informed my beliefs here. Who listened to Tudor's talk either today or yesterday? Yeah, you know what I'm talking about. The stuff is awesome. I worked on this, I worked last year with Pharaoh, and I'm not going to rehash his points, but what I'm going to say is I was a user. I can testify to just how good it felt programming Pharaoh with the Glamorous toolkit and how productive I was. And I don't care much about Smalltalk. As a language, one way or another, it's an okay language. I don't dislike it or I like it, but what I care about is writing programs. I was extremely productive in that environment without having to be excited about the language and having to drink the Kool-Aid. And I thought that was cool. And it got me thinking about how to get this kind of joy into other environments, right? Because functional environments are often very dire, tooling-wise. And if you have tools, they're often silos. And so what I'm going to talk about, if we have all of this information just lying around, is the information that Carp holds onto, what this information is used for, and how tools can help us explore those. And I'm going to start with macros. Macros are great. I love writing them. I write a lot of macros. I don't like debugging them. And I think that is a common story for everyone. List macros are incredibly powerful. Because of the homoiconicity, they're super simple to write. You can disagree with me on this, but I feel they're very easy to write. But they can be extremely frustrating to debug, especially if they pass all later stages of the compiler. Like you accidentally wrote code that type checks and that has correct lifetimes, but it does something completely different from what you expected. And that happens rarely, but it does happen. And it's super, super frustrating. And so the simplest thing that we can do is just expose to you what happened every step of the way. Before the expansion, while the expansion is happening, and after it has happened. It's not hard. It's a tremendous boost of productivity, but it exposes things that the compiler already has to do anyway. The compiler has to expand your things, and all we need to do is have hooks in the compiler for that, and then maybe expose it through tools. And type inference is similar. It's super useful because most types that you write in your programs are either extremely trivial, especially if you write numeric code, and it's all just numbers, or they're very painful to type, but easy to reason about. And I'm talking about higher order functions specifically. They get really tedious to type out or to look at very quickly. But you have functions that you use all the time, like fold operations, and you know what they are. I can reason about a fold operation very quickly, but writing out the type signature is often extremely annoying. That might also be because I have something that I call a type variable impairment. If you have too many type variables in your type signature, I just lose track of everything. I can't reason about it anymore. So that gets annoying in Haskell, for instance, with lenses. Whoever looked at lens type signatures knows what I mean. But I do need to find out what the types are every once in a while, especially when there was a misunderstanding between the compiler and me, right? I thought that was valid, but it actually doesn't type check. So then I want to know what was wrong. And then the last thing is borrow checking. And because that's the newest and most unusual feature, I might just go over that really quickly. Holy shit, I only have 3 minutes left. You have to ask more questions. I'm going to give you a bit of an intuition about what it is. And so basically what borrow checking is a way for the compiler to figure out the lifetimes of values statically, meaning it figures out when to allocate and deallocate stuff for you, and you don't have to do that manually, but you also don't have random pauses, which is what you get when you have a garbage collector. Okay, a question. Thank God.
Yeah, I need to use some of those 18 minutes. There are many, but I'll do one at a time. So I don't understand if now you're taking inspiration from Pharo. So I understand you introduced that, and the thing you're talking about now about like changes to macros and way to interact with the compiler, and like the borrow checker are you're talking about Pharo, or you're talking about introducing new things in Carp?
Okay, all right. So I guess I have to clarify that a little bit. So what I mean by that is that Pharo is super interesting in its own, on its own, but it mostly works for very dynamic systems, for something like Smalltalk. It is based on Smalltalk, and I don't know whether he said it in the last session, but Tudor has said it before. It was basically the only platform in which he could realize something like that. And I don't think that has to be true. But I also think that most existing systems are either like statically typed, more static systems, are either too complicated to try that out, or they're just plain intimidating, or they're not engineered for it. And so what I want to change is, Carp is it's reasonably uncomplex. The whole compiler is like 8,000 lines of Haskell, which is ridiculously tiny for the features that it has. And I hope that it's tiny enough that you can go in and write tools without having to understand, say, all of GHC, or all of whatever language that you want to use. Is there another question? Oh, okay. All right. Yes. So that's basically what I mean by that. Everyone fine on the on the borrow checker front? We have another question.
Yeah, I wanted to ask a little bit about the macro debugging system.
Mm-hmm.
What influenced you on this? I see that it's very vague what I've seen so far, so
Mm-hmm.
like if you can get into a couple specifics about what makes it special, and if you also took any inspiration, since we're talking about Pharo, from sort of the object-oriented sort of debugger style where like you're showing like, because I'm thinking of like a diff in macro state rather than like the entire software state, you know?
Right. Yeah. So one thing that I want, so the first thing is, what do the macros look like? And I know that you've worked with Clojure before, and everyone who's looked at Clojure before has seen kind of what our macros look like. They have the same kind of syntax. They construct things. You have a bunch more operations, like you can ask a type, what members do you have? Or what are the types of your members, and that kind of stuff, because we have that information may be available, depends. If you work on the type directly syntactically, but that's about it. So it's relatively similar to Clojure in that way. On the other front, I'm going to get to the tools, I hope, the state of tools in Carp. But really, what I'm talking about right now is the ideas behind what could all be exposed or looked at, because I want to get through garbage or borrow checking real quick, and then I'm going to revisit that conversation. Is that all right with you? Cool. All right. So what I want is, I don't want to deal with memory allocation, because unless I really want to enforce a certain memory layout for caching reasons, if we're talking about a game that has data-driven design and that kind of stuff, if I don't need to enforce this, I don't care about it. It's usually very mundane. It's not trivial, but it's mundane, and I don't need to deal with that. Also, I don't want my program to pause randomly, because that's bad if we're, again, writing a game, and that's the domain that Carp comes from, or that Eric comes from. But I do want to know when things get deallocated, because their scope ends, especially when I need to optimize things. If I need to figure out who owns what, and if I move this around, what changes, and what guarantees can I give. So, that's the big reveal. We don't have any of those tools. No, we do have some, but none of them are in any way stable. So that's the big letdown at the end of this talk. I do have a little insight into some more of this, but the big reveal is none of this exists. None of the tools are really there. You can inspect your types in the REPL and whatever, but that's not ergonomic, and so I don't consider those tools. Yes?
So let me just ask, the language supports references as a different kind of type from the kind of value types?
Yes.
Or, yeah.
So reference, that has to do with the borrow checker.
Yeah.
A reference is something you don't own, and if you own something, then it's not a reference but the thing.
Yeah.
And then I can take a reference to something and put it somewhere else, but then that thing will not deallocate or allocate this. So
Yeah.
that's how what the borrow checker does.
So,
basically,
let me just kind of make sure that I understand correctly, because I can see two kinds of things going on. Either the kind of thing that is being referenced to does not deallocate while the references still exist. That's kind of the garbage collection way or reference counting way. Or then the compiler doesn't allow it to pass compilation if it can't prove that the references are kind of gone away until the kind of the object that is being referenced
yes.
is allocated. So which is your borrow checker doing the latter
Yes.
kind of thing?
So basically what it does, what you can do, is you can say, I'm allocating a new string, or there is a new string, and I pass it into a couple of functions, and then I get it, and then I am responsible for cleaning it up in the end. So how we're doing that is by introducing let bindings, and while the let binding body is still there, that's how long the thing will live. That's all.
Okay, so it checks that you can't leak the reference outside of that scope.
Exactly.
Okay, thanks.
Yes. All right. So what we have done then is we built a foundation instead of having the tools yet. We built a foundation which is version 0.3. We released it, and what we now have to do is work on things like tooling and like libraries, and generally more interesting stuff than working on a compiler. Compilers are fun to work with, or to work on, don't get me wrong, but they're only a small part of the story. All right, so why am I here if I don't have anything to show you? Because I want to make clear that designing a language is about affordances, so you can choose certain features and some are at odds with each other. And what Carp tries to do is push as much work as we know how to do into the compiler, which means that if you end up doing all the things that might be possible in all spaces, like with type systems, then you end up with a very big thing. And Carp limits that by kind of emphasizing simplicity. And another question?
And yeah, you have 6 seconds. No, the question is, there's still one thing I don't understand about the borrow checking and copy stuff. Is this the right impression that the Carp language is not immutable? Or is this reference checking having to do with being mutable? Because I don't understand why you need this copy, and your examples are about arrays that are usually mutable stuff. So is there any distinction between mutability in Carp?
No, there are no distinctions between those things. And that has to do with, a lot of the things that we do under the hood are actually mutating. But for most types, unless they're kind of C types, all of the mutation things will consume the data type and return a new one. And then under the hood, the optimization is it's actually the same thing but mutated. So that's how we enforce kind of immutability. It's not really immutability, but it kind of looks like it is. Yes?
So I think that if you allow mutability and references at the same time, you have the danger of kind of invalidating stuff like iterator invalidation or something like that. So what's your strategy against that?
All right, so that's a good point. So maybe I didn't make that clear enough. The things that mutate happen under the hood. They happen in native functions in C that we just test to see that they work. And then what you get is a seemingly immutable interface. That it is mutable under the hood is purely a, let's say, it's not really true. It's a lie that we present to you as fact inside the language. Of course, you can invalidate things, though, because you can always drop into C. We have a good C FFI, because that's necessary if you want to do games and stuff. And there you can shoot yourself in the foot, as you always can in C. Okay. So to drive the last point home is tools can help us get the kind of the kind of value and the kind of velocity that we have in dynamic languages into more static languages. This talk has been interestingly focused on the borrow checker, but what I actually wanted to say is that what I hope happens is that we write more tools that can help us gain insight into our programs, and that don't suck as much as the current state of the art, basically, in functional languages. And so with that inflammatory statement, I'm going to end this talk. Here are references. Koalas are endangered, so the talk's main event, or the talk's main point is actually, you might donate to the Australian Koala Foundation. Thank you. Are there any questions left?
So in your talk, you talked about macros quite a lot. I don't know whether on my own here, but I think there's probably quite a few people in this room whose nearest points to this talk would be closure, where culturally macros are sort of not encouraged because it's seen, the function is seen as a more powerful construct because it composes. Is the difference in Carp because the language just works in a different way, or is it just a different approach that you've decided to go with? So why macros?
All right. So I think culturally I'm the one who's to blame because I'm the first person who wrote a lot of Carp, and I like macros, and so I write a lot of them. Ooh. I have a bunch of blog posts about like writing interesting features with macros. What I think is different as well on the language level is that we have all of these checks afterwards that happen, type checking and borrow checking, to look at, to help you figure out whether your program actually behaves. That isn't always true. You can still shoot yourself in the foot with macros, but it is harder because there are a bunch of checks that happen afterwards. Does that make sense?
So one of the problems you tend to see in systems that try to combine type systems and macros is that if you have a type error when you're using your macro, the error is given to the programmer in terms of the expanded code rather than the code they actually wrote when they were writing their macro. Mm-hmm. Do you have any ideas for Carp, whether they might be able to solve that problem in some way?
Could you state the problem again? Sorry.
Yeah, so I mean, say you write a let macro in terms of the lambda expansion, if you're familiar with that sort of thing. And let's say it's supposed to be typed in some way, and when the programmer goes to write a let expression, they get an error back that says this lambda application has the wrong type. And the programmer says, well, I didn't write that lambda. What code is that? I wrote a let expression.
Right. So something that we've been experimenting with is showing you the original location as well as the expanded location when you get an error. So if that thing happens to be inside of a macro or result of a macro expansion, that form, you get either or both. And we've been kind of trying to figure out which is better. And I think that having the original location is often good, or better than having just the expanded location, but also not the whole story. So what we've been trying to figure out is having both locations. Is that the right thing? Or maybe it shouldn't be part of, the error message in your editor, or maybe you need a different kind of editor to, as I said earlier, look at what happens during expansion and before expansion and after, and have all of these informations together to figure that out. Does that answer the question?
That's the question about the FFI for C. Is that for hardware hardware support mainly, or performance?
All right. So a bunch of things are currently, the FFI is used for a bunch of things. So a friend of mine, for instance, he's building synthesizers, like hardware Eurorec synthesizers, and he's building firmware, and you need a whole bunch of like C functions, and those drop into assembler then to do that. And so he's been experimenting with and writing firmware using Carp. And that's one example. But for games, you want maybe libraries like OpenGL, and you want to support them in a way that feels natural, but that also feels seamless. And because we compile to C and then a very simple code, you can basically just register all the functions as they are, and then maybe register the types, mark them as opaque, or re-register them, and then you have a working program. We also have a header parser that parses a header and generates the bindings automatically. So stuff like that we use the CFFI for. Cool.
So you talked about homoiconicity, and can you elaborate what you mean by that? Because it's always been kind of an obscure notion to me.
Yeah.
So just for more context, there's plenty of languages which have more elaborate syntaxes, but they offer a quasi-quotation ability that reflects the syntax that's available in these languages, and so you can basically express syntax manipulations without too much trouble either.
Right. So what the basic idea, so I think the Lisp community talks more about homoiconicity than other communities, but you have homoiconicity in a whole host of other language families. I wouldn't count quasi-quotation as homoiconicity because what I really want is that all my code is a data structure that I can manipulate. And so the simplest way of looking at that is Lisp, maybe because it's most familiar to people. And there you only have lists, and maybe arrays, but mostly lists and maybe symbols and literals. But it looks the same in the abstract syntax tree as it did in the source code. You don't have to transform it in any way. And so that's why that's what I mean by homoiconicity, and that's what makes macros relatively simple, because you can easily reason about that if you look at the code. Does that answer your question? Does that make sense?
I mean, you can do the same with like Haskell macros or Scala macros, where you manipulate the source code directly as data, and in the pattern matching part, in the patterns of pattern matching, you just write a quasi-quote with holes, and so it allows you to just, it's just a more elaborate syntax for manipulating code as data, but I don't see a difference.
I wouldn't say that one is strictly more powerful than the other, but I definitely see a difference. There is, so on the one hand, what you have is you have a language that allows you to insert things into the source code, quasi-quoting. And on the other hand, you get the source code as a data structure. You can traverse it, you can insert things, but you can also analyze it. You can do all kinds of things with it, which for most languages, and I would say Haskell included, this is a lot more intricate. You can do all kinds of things with template Haskell, for instance, and so on, but I wouldn't say that it's very simple, and I wouldn't say that it maps one-to-one, so the code and as a data structure maps easily one-to-one.
Okay.
Presumably you've seen Hackett.
Sorry?
Presumably you've seen Hackett.
Yes.
I was wondering if that would help solve some of the problems of macros, etc.
So I see two very very clear differences between Hackett and Carp. Hackett has a lot more of the Haskell type system, that for one. We have a way less expressive type system by choice. And then the other thing is we compile to C and have the borrow checker. So Hackett runs on Racket, or last time I checked it did. And so that's a difference because you have the Racket virtual machine and so on underlying all of that. Where I guess they ported Racket to another scheme recently. I don't remember the details actually. Yeah. Okay. That was it.
Just one point to mention in terms of homoiconicity. There's a good blog post out there by Dave Herman titled, I believe, Homoiconicity is not the point, read is. And for me, it was just a very good clarification of what kind of do people mean when they say homoiconicity, and why is it really the case that S expressions and Lisp especially is really good for macros. I guess my short summary to do a bad impression of his work is that with Lisp and other S expression-based systems, you can get an abstract syntax tree, like some sort of parse, without knowing all the different forms in the system. You don't need to know about for loops or while loops or if statements, things like that. But you can still get some sort of tree-like structure by just looking at the parentheses structure of the code. Whereas things like Scala and Haskell and things, you need to know a little bit more about the system. So he goes into more detail anyway in this blog post about why that's really the important property for a really strong, powerful macro system. So, just something I recommend to people.
Cool. Just to say something to that point real quick. There's also an interesting talk out there whose title I can't remember, but if any of you approaches me, I will look through my YouTube history. Or I have a repository on GitHub where I keep track of the talks that I watch, and it has homoiconicity in the title. And I remember that it was a very good overview. It was given in the closure context, but it applies to all Lisps, basically.
So you mentioned games a few times, so I was wondering, all these features you were talking about that you integrated into the language, were they driven by the fact that Carp was mainly built for games, or is that just because games are a fun way of showing a language at work, or?
So I think the initial idea was that Carp is a language for games, and I came along and said, I don't care about games. Let's make this a general purpose language, for better or for worse. Maybe for worse, because sometimes DSLs are better expressing domain-specific context. But I think that the language is interesting enough to be considered outside the context of games. That's it.
Okay, well, thanks to the speaker again.